Hello and welcome everybody. Today we have this awesome Hedera Technical Community Call. I met Marquez from the DevRel team at Hashgraph. And today's call is going to run in two segments. In the first 10 minutes or so, we're going to have Ty Smith from Hashgraph, and he's going to walk us through a very common but a very important topic, which is choosing a key for your development or for engaging with applications on Hedera. And so he's going to give us some insights into the implications and the considerations for choosing your key. For most cases, I would argue that ECDSA is a strong choice, but we'll get the full picture from Ty once he does his deep dive. Now, in the second segment of the call, which is going to take the rest of the space, we're going to have Michael Kantor from Hashgraph Online, also joined by Keith Perry and Connor Snitker from GoDaddy. And they're going to cover a new open standard for AI identity, right? So this is a new standard that was built with GoDaddy ANS, or Agent Name Service, and also integrated with the Hedera Consensus Service. So let's kick it off and let's bring Ty to the stage. Welcome, Ty.
Hey, happy to be here.
Awesome. You've joined us for many of these calls in the past, but just give us a refresher about who you are and what you work on.
Yeah, so I've been in the ecosystem for about 6+ years. Initially was a community developer for about 3.5 of those, and then joined Hashgraph. And then I focus on the tokenization, some AI strategy, the Hedera Consensus Service, and then just how to help developers and how to make sure that the Hedera mainnet is exactly what everyone needs on the planet for everything.
Amazing. That's quite a lot of ground covered, Ty. So with that in mind, please take it away. Let us know, give us the full picture on, what should people consider when choosing a key, and probably what's the way to go for depending on the case.
Yeah, it's a super fun, highly engaging project, you need to know it. It's the base foundation of pretty much any platform you're going to build. Is what are your customers going to be using in accounts, and how are they going to be signing transactions to have validity of identity and interacting with the Hedera mainnet? And then there's a lot of nuances in which key type you should choose, especially with EVM compatibility, being able to easily interact with Solidity or send Ethereum transactions right to the JSON RPC. And I'm going to go through all of these fun low-level things, presumably right now.
Let's go for it.
Awesome. So this might not be the most engaging, but I do think this is probably one of the most important decisions for anyone deploying any platform or interacting with the Hedera mainnet, which is what kind of key are you going to use for the accounts interacting with your platform? We have a very unique system on the Hedera mainnet where the ability to use ED25519 keys, which was the native Hedera, the initial rollout of Hedera used this key type. And then when EVM compatibility came around, ECDSA SEPTA 256K1, which is the native EVM keys, were also added to the mainnet. And so you have this ability of choosing a key, which is very unique to the Hedera's mainnet. There's a lot of confusion / there's a lot of nuance in these two different key types and what they can and cannot do on the network. So this presentation really is trying to go over the decision-making process of when you're launching a platform or when you're engaging with the network on what key type you should get and why. What are the benefits of each of them? Not to skip to the end, but the best compatibility key will be the ECDSA key with a EVM native alias, and I'll go over what that means and why right now. So here we can have like a breakdown of the two different key types, and both can sign Hedera native transactions. So ED25519, ECDSA, both of them fully function on the Hedera native layer. When you go down into the Ethereum layer or the EVM, when you're interacting with Solidity, when you're sending Ethereum transactions right to the JSON RPC, there's differences in if an ED25519 key can correctly sign. And there's differences in Solidity logic on if the Solidity can understand the identity of your key the way that it expects to, as it would on other EVM networks. So here we can see the first divergence is Ethereum EOA or externally owned account key system. When interacting with Solidity, it doesn't have the ability to understand ED25519 like it would an ECDSA key as an externally owned account. The one thing about the EVM compatibility is that when you create a key on EVM, it's typically you have a private key, and then your public key or your account is derived from that private key, and it is an address that you send tokens to, or you have a space on a ledger inside of a Solidity contract that you own X amount of an asset. That is not derivable from an ED25519 key. So you lose some of that functionality when you're going deep into the EVM world and using things like EC Recover, or trying to interact with a contract that's going to use your public key as a validation of your signature. It starts to diverge just because ED25519 doesn't act the same way. They're just two kind of different standards. And so when the EVM is interacting with an ED25519 key, it sort of gets confused. Another really good one was like signing Ethereum transactions vanilla. Hedera is really good at providing an ability for ED25519 keys to not feel this friction as much, where it wraps a Ethereum transaction in a happy transaction when you send it to the RPC, and then it will actually validate it so that you can still interact with things like, if you have an ED25519 key, you can interact with saucer swaps smart contracts. You don't get boxed out. But the deeper and deeper you go into this DeFi realm, and the more and more we get the compatibility with things like Layer 0 and Axelar, and like Bonzo brought Aave v2 over here, and the lending, and just all of these Solidity and EVM native things coming to the Hedera mainnet, the ability for the ED25519 key to feel like a first-class citizen is going to degrade. And we don't want that for people, especially for platforms that are starting now. We want them to be aware that it is much more forward-thinking, or heading off the changes that are coming and making sure that you're ready for the future of more and more Solidity contracts and different functionality, that if you just create the ECDSA key with the correct EVM alias, your users get all that benefit. They can easily directly interact with all of the native EVM things that are coming, and they lose no functionality. And then there's one caveat in there that I'm going to talk about at the end. So the main difference between Hedera and EVM is that Hedera is an account-based model with balances, and EVM is not. So when you have an account ID, that account ID can be looked up, and the balances of the tokens or the HTS tokens that you have can be seen in that balance. In EVM world, it's more your public key. So like say you have an ERC20, your public key is put into the Solidity contract along with the amount that you are allocated of that ERC20. And so the balance isn't on a lookupable table of your ID. It is your public key is put into a key list inside of a Solidity contract. So it's just two fundamental different systems, and we've combined them. So you can still use both, but in that, there's some complexity / things that EVM assumes are going to work, that if you create the ECDSA key with an EVM alias, totally works fine on Hedera. If you do the ED25519, there's these slowly nuances that will get confusing. So here we can see this native account ID. If you create an ED25519 or an ECDSA and don't set the alias or the EVM address, you get something like this, which is a long 0 EVM address. So your account on Hedera is represented in EVM in the structure that it expects. The only problem is that this long 0 EVM address is not the public key of your private key, which is the expectation. It is a made-up long 0 EVM address that can still be a pointer and an identifier. You can still interact with it. But the second that Solidity contract is going to try to validate your key through that long 0 EVM address is where the divergence of functionality happens from ED25519 and ECDSA. And then down here, this is what a real EVM address from a public key would look like. And again, you can absolutely create this correct looking EVM address on Hedera when you're creating the accounts for your platform or for your use. And that is going to give you full functionality of everything that the EVM expects from that key. This is sort of the breakdown of the three options that you have. ED25519, Again, that was what we started with on the Hedera native transactions, the Hedera native services. And just I wanted to comment on some, I think, historical misconceptions on ED25519. They are not more quantum secure than ECDSA. They are both on the elliptic curve. And so both of them are as quantumly secure as each other. And when one would ever be broken by quantum computers in 5 to 10 years, the other would also, because it's the same curve. So the one benefit that ED25519 typically has is speed. It is a little bit faster than ECDSA, but on the Hedera mainnet, because we accept both keys, there is no speed factor. It is exactly the same because it's been normalized across both keys. So signing something with ED25519 or signing it with an ECDSA, you're going to get the same exact consensus time. So there isn't really a difference. The middle one, ECDSA without an alias or an EVM address derived from the public key, you can create these. It would create that long zero address I showed, and it's really just you should just go all the way. There's not too many benefits to having a long zero EVM address. The only one is if you know you're going to rotate this key. If this is the key that you're going to give to someone for a quarter for a business reason, and then after that quarter to be SOC 2 compliant, you're going to rotate that key and give it to another business person, or you just have to have that SOC 2 compliance inside of the system that you're utilizing, then you should create the ECDSA without an EVM address. Other than that, you should always just create the ECDSA with derived alias. If you're creating a platform, do the same thing. Even if you're not planning on interacting with EVM, we would still encourage the ECDSA with derived alias, the EVM address, because if you do in 2 years eventually want to expand or use some functionality in there, it's very easy to just get all of your users on your platform or to use your personal account in that way, and you don't lose anything. The only exception would be rotation, and then you would use the ECDSA without that EVM identity. This is how sort of like they're created. I'm not going to spend too much time on this, but when you generate an ECDSA key, it derives the public key from that private key, and then it derives a 20-byte EVM address, which is different than the straight public key. So EVM does use a 20-byte EVM address truncation of that public key, and then you can create the account, and then you can set that address as the EVM alias. This is what's happening behind the scenes. If you're using an SDK to create an account, just use set ECDSA key with alias. Boom. Now you got it. It's really, really easy. It's just one command, and then as you're creating these again, you have that forward-looking account key. This is just trying to like conceptualize all of the differences here and all of the various different letters and words I've been saying and numbers. In the left, we see the native, Happy, HBAR, HDS, HCS, native signatures. On the right, we see Solidity, JSON RPC, Ethereum transactions, Ethers Web3, Ethereum wallets, EVM wallets. If you create the ECDSA with that EVM address, your one identity works everywhere. It's just a one and done. And at that point, that's really what we're trying to convey, is that this is the best way to make sure your platform that you're building and the accounts you're onboarding are forward thinking and will always be able to use any of the services, whether native or EVM. And if you're just creating a personal account, it's the same thing. You can create one account and then have that forward flexibility as the chain goes forward, and EVM compatibility and EVM developments just keep going forward. So just to bring it all together, create with ECDSA, derive from the same key, and set that address as the alias. Very easy, one line in the SDK. Anytime you're creating a key, highly recommended. The only exception, which should be very rare really, is you're going to rotate it. Even if you're building a multi-threshold key, still recommend the ECDSA with the EVM alias. If you're going to rotate, just don't set the alias, but still use the ECDSA, and you should be great executing transactions on the network and creating your awesome platform that you're creating. Thank you. That's it.
Awesome. That was a great overview, Ty. Ty, in terms of a quick question, just to try and summarize it as much as possible in my brain and hopefully here for the audience. So as I understand, the EVM address for an account can look in two ways, right? I think you mentioned the zero long form and also the EVM standard form. could you help us remember which one or what each one of those is derived from? I think you hint at it, but if we could get that summary, and then maybe what should a standard EVM address look like, and what is it derived from, is the question.
Yeah, so if you have a long 0 EVM address, it was derived from your Hedera account ID. And so that's why you always have those long zeros, because the 0.0 in the hash, or how it was derived. And then if you have all of the numbers and letters and stuff all the way throughout the 0x, that is the correct 20-byte public key. So you don't want the long 0, again, except in that very rare case that you're going to be doing something with SOC 2 compliance or continually rotating. But yeah, that's you don't want the long 0. In most cases, you want that really nice looking GUID of a bunch of numbers and letters.
Sounds good. Yeah, it sounds like that EVM address should be derived from the public key.
Yes.
In the case of ECDSA accounts, which is the one that makes it work very easily and smoothly on both realms, the Hedera native side and the EVM side. Cool. All right. Well, Ty, thank you very much. If you can hang out with us here in the backstage, we'll bring you back up for the Q&A at the very end. But at this moment, I would love to bring the other guests here to the stage. So we'll have on the stage Michael Kantor. Very well-deserved applause. Michael Kantor from Hashgraph Online, and also Keith Perry and Connor Snitker from GoDaddy. Guys, it's a pleasure to have you all here. Please give us quick intros for each of you, and then who you are and what you work on. Michael, let's start with you, and then we'll go to Keith and Connor.
That sounds good. Hi, everyone. It's Michael Kantor, and many of you know me as Kantor Codes on X and LinkedIn and so forth. It's a pleasure to be on the show. As always, I'm the president of HLL. We are an open source standards body here in the Hedera ecosystem. Well, no, I'll pass it here to Keith and Connor.
Hey, Keith Perry, principal engineer at GoDaddy. Decade of experience working on domains and naming websites, and now transitioning into naming agents. Connor?
I'm Connor Snitker. I'm a principal engineer at GoDaddy as well. Been doing this about 15 years, and excited to be working on ANS and AI in general.
Amazing.
I was just going to say real quick, love the shirt, Michael.
Thanks, Keith. I appreciate it.
Awesome, guys. So please take it over. What do ANS and consensus have to do with the Internet of Agents? These are interesting days, with the agentic activity popping up.
Yeah. I didn't know if there was a second question. It echoed a little bit for me. Yeah, absolutely. I think this is a really big title, and it also is the same presentation we did Rare Evo. You kind of think about it, it's like DNS, ANS, these all feel like really big terms. And I think for a lot of folks in the audience who are less technical, who have probably registered a domain name on GoDaddy at one point, you are really curious, what do these things have to do with each other? So I'm gonna share some slides on my side real quick. I won't spend too much time on it, but I want to paint a little bit of a picture first here. Tell you guys about HLL in more detail, some of the standards that we're working on, and how that kind of translates into the work that GoDaddy has been doing, how ANS is important. So number one, for those who don't know too much about HLL, we are, again, open source standards body. We build AI standards. We've brought together 40 plus organizations, rapidly growing. Essentially, what we do is we contribute open source standards that are helping shape the new agentic internet. We do that through agentic tooling, through standards inside of the LFDT called the Hedera Consensus Specifications, which now have almost 1,000 stars on GitHub, by the way. It's pretty awesome. And our big mission and goal is we want to create standards for a safe, secure, and scalable agentic internet. What does that mean? Well, we talked to a lot of folks, and there is a consensus, and obviously consensus is a word I'm using really specifically because we're here at Hedera Stream, right? Consensus really is about coming to an agreement on something. And there are studies and research that show that we're probably going to have at least 100 billion AI agents out there in the wild, maybe even close to 1 trillion. This is backed by the work that MIT is doing with Project Nanda. And when you get to that level of scale, naturally people start wondering, well, That's a lot of agents. That's a lot of computers. That's a lot of GPUs. It sounds expensive. It's a lot of egress and a lot of things to consider. How is it going to work? How are we going to talk to these agents? How are we going to find them? How are we going to shift through the noise? If you think Google is bad, think about what a billion, a trillion, hundreds of billions of agents is going to do for you. And how do we know, most importantly, that we are doing business with agents that we can trust and identify, that we're not talking to an agent that is based in a sovereign area that we don't want to do business in, right? That we know that we're not getting scammed, that we're not sending money to a pixel ordering scam of some sort, right? So these are big questions. And through the work that we do at HOL, we've brought together all these organizations that are building an AI ecosystem to kind of answer them. We come up with things like agentic trust scores, identity solutions, communication solutions, and privacy solutions. That's what we kind of do. And we do this through an open contribution model, which is very much inspired by work that's being done within organizations like the Linux Foundation and the IEEE. So essentially, anyone can come in and they can contribute through open source and open governance. They can come with initial standards. So standards, I think, have really been foundational for the internet. If you think about things like SSL or HTTP or TCP, all of these things really start from being a markdown file somewhere, like a text document, to even simplify further. It's basically just some rules on a piece of paper that folks have come up with, and they said, hey, these things matter. This is how we want to structure this. But conceptually, even if you look at the Hedera blockchain with the HIP process, none of it matters until it's actually running somewhere inside of a service, right? And that makes it magical, because now you have these participants who decided that they looked at this standard or the specification and said, yeah, we're going to use this. When you use your browser for the first time and you're turning on the internet, there are hundreds, not thousands of standards that make it all possible. Then they just started as text documents. So with HOL and our contribution model, it's not any different. We start with these text documents, contribute, bring them to fruition, and then we work with organizations to bring them to life inside of SDKs, tools, and applications. Then we work with partners external to the organization who have real use cases and demand for these things. So if you're interested, number one, in contributing, do reach out. You can go to hol.org and you can apply to become a partner in our partner program. Through our history, HOL has had a lot of success. We've already published over 20 plus standards. Now we're getting into HCS-30, so you can see how it's a little bit of a hockey stick here. We've got over 4,000 GitHub stars and 1 million plus package downloads. If you go on Google right now and you type in Codex plugins, we come up as a second result on Google. We've built one of the biggest OpenAI Codex marketplaces, where there's now over 150 plus contributors and close to 1,000 GitHub stars and folks who are participating in that. And the coolest thing is if you participate a plugin, you show up in the HOL registry as well. Inside of our partner program, we're backed by a founding cohort of over 30 plus organizations, like GoDaddy, XMCP, Horizon Labs, Open Matter, so many more. These organizations have come together and they've started to create working groups to solve some of the problems that we're really interested in. And really, if we kind of zoom out and think about those problems, there is a new Tower of Babel, right? And that kind of comes with the growth of AI, the adoption curve that we're seeing today. Everyone's really excited about AI. They've got all these new fancy tools. They're getting Fable, GPT-5.6, and open source models. And like, okay, I can do this too. I can participate. I can build onto that. And what we start to see happening really quickly is lots of flavors of some of the same things. You see so many startups are looking at, hey, we're going to make a coordination layer. Hey, we're going to make an identity layer. Hey, we're going to do X, Y, Z. And there are hundreds of these solutions just piling up. And these solutions are sporadic too, because they're between enterprise and cloud ecosystems. Some of them are between Web3, decentralized distributed solutions. And a lot of these solutions don't actually work well together, right? There isn't exactly a continuity between these different solutions where you can just tag them on, right? And that creates a little bit of fragmentation. And I'll be a little bit, it might sound contrived, but I think it's okay that there is fragmentation. Actually, most engineers would probably scoff at me and say you're crazy, that you think it's an okay thing. But if you look at historically how the internet has gone up, there's never been one implementation of X. And when you look at the behavior of AI agents and the number of things that they're going to have to support in the future, if you try to fit everything into a single square hole, you're going to run into a lot of problems at scale. You're going to run into so many reasons why this can't really work, right? So typically what happens to industries and technical adoption is you have different flavors of things, and those different flavors are okay. So agents will naturally have different ways to communicate. We've already seen early implementations of these standards like A to A and MCP and so forth. So they'll have to behave differently based on their circumstances. They'll have to behave differently based on where that agent is sovereign to, like what country it's in, what company it's in, what regulatory body it's beholden to. For example, an agent that is giving you advice, like medical advice, is going to have a very, very different legal system or legal framework that it has to pay attention to, versus an agent that's giving you financial advice and trading on your behalf, or an agent that's just selling you domain names, right? So that's going to create disparity in many communication protocols. Like, what do we have to log? What is HIPAA? What does that have to do with anything, right? And when you contain all these things, you realize, okay, there's probably no way we could put this in one implementation. With discovery, it's the same thing. And for technical reasons, you kind of think about it as like, if you have 100 billion agents, maybe even 1 trillion, if you put all those agents in a single system that everyone pays attention to, and that's the only way where you can kind of find these agents, then you come with some risks, right? What if that system goes down, if it's not decentralized or distributed? 2, can you even fit that many things in one system? 3, you probably have a lot of agents that you don't actually want public to the internet. You have intranets that many organizations will run, hundreds of thousands of agents that are really just made to interoperate within their own enterprise, right? So those shouldn't necessarily go in the same public box, and you need a solution to connect those things. In Hedera world, we kind of look at that as Hedera and hash spheres, right? And then reputation. Reputation is such a contextual thing. So for example, we're working on trust adapters, and with the trust scoring system that we've developed, we kind of think about it, hey, you pick which trust adapters you want, put it into your registry, and you use those. Because contextually, if I'm talking to an agent that gives me financial advice, how I'm going to score that agent is very different than an agent that is going to give me medical advice, right? So there's going to be many different signals. We want to register all those signals, but we also don't want to force you to have to use all of them, because that just wouldn't make sense. So to bring it together, fragmentation is going to exist, and I think it's okay, right? So on the topic of fragmentation, one of the cornerstone standards that we've worked on is called the Universal Agentic ID, or HCS 14. So HCS 14 is basically a string. You could put it anywhere, and I mean anywhere. You can put it on the API, put it on blockchain, doesn't really matter. All it is a reference that any human can look at, and they can immediately understand, hey, this is the agent's ID. Hey, it belongs in this registry. Now I could go find its ID in that registry and get everything I need to know about it. So as part of the standard, there are 4 components to it. First one is a DID specifier. So if you look on my screen, you see a little thing that says DID. And then DID is basically a identifier that's been built out over the last years, and it works really well, because with DIDs there are a number of methods that you have to generate a DID. So that's where we come in with the second component, where we say, okay, which method do you want to use? So either you're using a DID ID or you're using an AID. AID is artificial intelligence ID. So basically, you get that by looking at the registry, pull out 6 signals that anybody can get at the same time, and they're able to get that same ID. And the cool thing about the AID is that anyone can generate it deterministically, which means if you have the same information from the registry and I have the same information from the registry, I can generate that ID. And what's cool about this is the agent doesn't have to register somewhere. They don't have to manage a whole bunch of IDs. As long as their information is the same, that ID will be consistent, and anybody can replicate it. Component 3 is a unique identifier. So for AID, that's a SHA-384 hash of its core data. And for UA, that would just use the agent's existing DID that they've registered somewhere, like a Web3 key or on a Web2 auth system, right? And then the last component of this is a key value pair. So essentially, you can kind of think about it as these are miscellaneous parameters, which is probably the coolest part of the standard if all the other stuff doesn't really matter to you. With component 4, you can see the registry the agent's on. So you can see in my screen here, the registry, HOL, protocol, HCS10, native ID is the ID in that system. And as a user, as soon as you look at this, you know, okay, I can go to this place and I can find that agent. So another example of that I know that the GoDaddy team is going to cover is how does this work with ANS? Last thing before I kind of head out here real quickly and pass the mic to Keith and Connor. At HL, we've been really anxious about security. So if you're vibe coding or using tools like Cloud Code and Codex, there's always a risk that your agent will delete your whole file system. There's a risk that it will decide to send over private keys over egress. There is a risk that another agent will talk to it and prompt inject you. And we've built this open source solution that anybody can download and install now to get immediate value from. That'll protect you from these kinds of attacks. It's got over 500,000 downloads and growing very, very quickly. And there's a lot of opportunities too for startups and developers who are watching this. In our 3x release, you can actually go and contribute extensions to this so that we have support for your startup skills, MCP servers, and so forth. If you're interested in getting HL Guard shot, you can scan this QR code. I'm sure it'll be saved in the presentation as well. Just go to hl.org/guard to get more information, or hl.org/guard/install, where you can install it in a single command. So those were a bunch of words, and I hope that you guys found value on it and paint a little bit of a picture of some of the work that we're doing here. So without further ado, I do want to also pass it here to Keith and Connor, who are going to tell us all about ANS and the open standards that they have been working on.
Yeah. So kind of the problem that agent name service tries to solve is agents can't really prove who they are. Currently today, there's not a great discovery method. You know, if you're looking for a translation service, for example, how do you know which one is a good, you know, quote unquote agent that you want to interact with? And then if you do find an agent that you want to interact with, how do you know it's the real agent and not a lookalike? And then sometimes identity isn't enough. So even if you have this agent that you find that you want to connect to and it is a real agent, would you really want to share payment information with that agent? So ANS has, it's kind of built on top of 3 primitives, and they all have one job for this verifiable identity. One is the X509 certificate. So if you go to, you know, you open up Chrome and you type in www.godaddy.com, you'll see that, you know, green padlock on the left-hand side. That kind of represents, you know, that this particular site has a certificate. We also issue a, you know, a version-bound identity certificate that can be used for signing requests with. And then the next primitive is this transparency log. It's like an audit trail for registration and lifecycle events for the agent. And then it's also based on DNS or domain names. So you know, if you're typing in hol.org, and so that name kind of maps to computers behind the scene. That's kind of how DNS works. So it's also based on that as well. So why do we pick DNS? ideally, we don't want any walled gardens. We're hoping for, we think an open internet is a better internet. ENS has, 30 plus years of it working well. It scales. It's fast, 100 million requests per second. But additionally, it has that openness as far as, all clients would know how to verify with tools that already ship. So it's already something that's existing. We're not reinventing the wheel. And then these agents are checkable, so it becomes answerable, but the same way that you check for a website, right? You can see that relationship go back to the domain name. And then also interoperability between companies or between systems, it just works out of the box because it's already a standard that's already built. But kind of the stack that we're built on, I kind of talked about the 3 primitives, but also HES 27 is in there and HES 14. ANS was originally built off of an IETF draft that it wasn't written by GoDaddy. It was an open standard. And it came out of an OWASP, a security framework or a security organization. So that's kind of what it's built on. And then on top of that, we kind of did a proof of concept of that. And then our VP, Scott Courtney, he co-authored a version 2 with a lot of the original authors of the IETF. But kind of the point here is that we're built on all these open standards. We want this to be open. We hope that there's many of these ANS reference implementations spun up. So we did release this. This is, we have intent to launch this with the Linux Foundation. So, please take a look and come play and figure out what's wrong. But then on top of that, we built this agent integrity monitor. So once an agent gets registered, we attest or we verify certain things. So we just make sure that is still verified as time goes on. So like if a service cert would get swapped out, we make sure it still matches what's in that audit log. And then on top of that, we built this. We realized like people are going to be registering their agents, right? And they want to get this data out, right? You can put all the data in, but everyone wants to get the data out. So this agent trust discovery is kind of like a search platform, and it does provide trust scores as well, but you can also do a semantic search. So if you're looking for, this travel agent, it'll bring back all the travel agents and then their associated trust scores. So how do you get an agent with agent name service? You start with a domain name that you control, and then if your agent is running somewhere, then you also provide this metadata. And so again, if you go back to the previous slide with the agent trust discovery, you kind of put whatever metadata you want that people would be able to find your agent. And then what the registration authority does. This can be any ANS provider. It doesn't need to be GoDaddy's instance of it. But we validate the domain control, that you actually have control of that domain. We return these DNS records for you to publish. And then we construct this like ANS name. Oops, go ahead. And then this gets sealed into the transparency log. And then what you get out of that is you get an identity certificate to sign with. You get this transparency log badge. And then your agent is discoverable not only by DNS, but also by the registry and that agent trust discovery I talked about earlier. And then agent calls, receivers can verify. So you have this identity. It doesn't do a lot of good if no one can verify it. So I'm just going to walk through a scenario here, kind of use an analogy to kind of bring it to everyone. Just imagine you have a passport and you're walking into an airport. Who are you? The passport kind of says who you are. And for us in ANS, that's kind of a skit receipt. it's cryptographically bound to the transparency log. So an agent can send that as a header to verify who they are. And then the TSA agent, is going to check that your passport is, not expired. It's revoked. You're in good standing. And that's kind of the status token that an agent can send as well. And then they also want to make sure that, the person that is there is actually, on this passport document. And so almost like they're taking a picture, when they're taking a picture of your face for that facial recognition, your face matches that photo. And, in the ANS scenario, that's the dPop or MTLS cert that you send along. And then outside of ANS, you can put OAuth 2 on top. But so in that case, a boarding pass has to be valid in 2 ways. Well, you have to have a boarding pass, number 1, to get on the plane. But then 2, it also needs to be, for that particular plane that you're trying to board. So you can't go to gate 4 if your boarding pass says gate 2. So that kind of just walks through a little bit of the whole gamut of what to do with verification with ANS. I'm just going to talk a little bit about us bridging the gap with Web 2 and Web 3.
Yeah, thanks, Keith. So if you want to go to the next one, we could start with the HCS 14 profile. So we have, like Michael went over earlier, HCS 14 is for resolving an identifier to an actual agent. Our implementation here, you can see an example down below. It all starts with a single DNS query to get the ANS text record. And this contains the version, the protocol, and then the endpoint information. So everything you essentially need to connect. So that's the first 3 steps here. We have a 4th optional step, which I'll get into in a second, which is how we're integrating with Hedera. But that 4th step is the transparency proof. There's another DNS record that you can look up that points to the ANS badge, which has all of the cryptographic information you would need to validate that an entry is not tampered with. So HCS 27, the ANS Transparency Log Checkpoint specification, we can sort of walk through an event here, say a key rotation. Every event is published to 2 locations, the first of which being the transparency log, which has the full event data, what changed, and again, that cryptographic proof that you can use to independently verify. The issue with only publishing it there, though, is it requires trust in an individual party, for instance, GoDaddy. And so what we've worked with HOL to do is publish the tree size along with the root hash, which is a commitment. And then the most important part, the previous linkage. And that points back to the previous checkpoints so that you can see from the first event all the way through the billionth event that nothing has changed, and you can independently verify it without having to trust our word for it. And so we can see this sort of all together on the next slide here. These are all essentially built on a principle of don't trust us, verify. We start with HCS 14 for the resolution. And if we go through to that optional step 4, we end up at the transparency log, which has all the information about the registration, registered date, key information, tying it back to Keith's example with the agent-to-agent communication. All of the data needed to validate an agent at runtime is located there. And we anchor that then on Hedera for that independent verification. Let's see, next slide here. So just a little background on where we've been working. Like Keith said, we have the IETF draft, which was originally co-authored by OWASP, Distributed Apps, and Cisco. And then the intent to donate the ANS specification to AIF Linux. And then, of course, this community and HCS and HOL. Open standards make ideas great. The more minds we can get on it, the better. And then, just a special thanks to Michael and the HOL team for being great partners. And then the ANS core team, Ben, James, Jeremy, Jimmy, Chung-Wei, Brad, Lukey, Scott, and then, of course, Keith. And then this is the location of the open standards, the HCS standards, and the IETF draft. I believe there are some links in the chat if you want to go out there, poke some holes in them, download them, build on them, report any feedback you have.
Awesome, guys. Michael, Keith, Connor, any other last thoughts before we dive into the Q&A?
No, just like a few things to highlight. I also realized my mic was totally going off my MacBook earlier, so sorry for anyone whose audio got slaughtered earlier. This number one, I think the coolest thing about ANS, like Connor was talking about at the end, is this was originally a standard in the IETF. And you had Scott Corney and a number of others who kind of work on that, and they looked at it, was like, hey, there's already something off the shelf here. Why don't we see if we can use it, we can build on top of it. So they did that. They created a V2 version of it. They shipped it on GoDaddy. And then they took it a step further and they're like, well, open source is really important, right? So then they did this intent to distribute LF, right? To put an open governance around it as well. They worked with organizations like ours at HOL and many others too. If you go to the agent name service on GitHub, you see other organizations who are also participating. Keith briefly mentioned around the Agent Trust Index too, which is seeing some contributions there. And it kind of speaks volumes to the whole open source distribution, right? And you're building something this important, you need to bring in a lot of different organizations and people to participate so that you get that reach and you also make sure that it's hardened, right? There's no more hardened software than the one that is totally open source and anybody can see and poke holes at, right? So I'd say for the folks who are watching the stream, check out those links at the end, participate and become a member of that community. I know that's a major thing that is important to this and for shaping what looks like one of the most important pieces of the infrastructure for this new agentic internet. I think the other thing too is really interesting when you look at HCS 27 as being a vehicle that you can have cryptographic proof of, hey, this root hasn't changed. And there's a couple of other standards that are also being built in parallel. Aside from HCS 27, which verifies the transparency checkpoint, there's also a new standard for transparency streams where you've got the root of the entire ANS Merkle tree, but next, what if you want to verify an individual agent and get that data as well? So I think that's going to be really cool. Those are just some of the things I wanted to add before we kind of jump to Q&A.
Amazing. Great points, Michael. And I do want to continue one more question or one more point about HCS. This could be a question where you can help me out here. But with HCS 27 being that transparency log checkpoint, can you make it a little bit more tangible for the audience and help us understand, without HCS 27, what could a bad actor get away with in a registry like ANS, and what can they not get away with anymore now that it's you have this primitive available?
Yeah, so I think what we gain from publishing these checkpoints is essentially it prevents any one operator from being able to rewrite history. So with any form of Merkle tree or history, any log anywhere, you essentially have to maintain a copy of that log forever so that you could independently verify it. But if you weren't watching the past, nothing would stop us or any other registry operator from actually modifying that history. And there would be no way to tell. And so the big benefit there is when we start publishing these checkpoint routes out to Hedera, that sort of is taken away. You're not able to silently rewrite any history.
Makes perfect sense. Thank you, Connor. All right, folks, let's jump into some of the questions we're getting from the audience here. We'll just go in the order that we received them. And so the first one being, when HLGuard inspects new MCP server registrations, how should runtime security evaluate monetized MCP tools that require X402 HBAR payments before granting tool execution? Michael, I know you provided an initial response quickly in the chat, but if you could cover the details here for everyone's benefit, that'll be awesome.
Yeah, well, the answer to this was pretty short because that's not really what HLGuard does. HLGuard is more local first. So you run a bunch of MCP servers, and then basically what HLGuard is the world's largest dictionary for terminals and skills MCP servers. So by that, I mean, like, okay, you've got AWS, they have a command line interface. So we register that, we get all the variants of those different commands, and then you click approve or deny, and you set up your custom configuration. Now, when your agent is doing stuff and it tries to delete something in your AWS, then it'll get stopped automatically. With MCP servers, it's kind of similar. You register your server locally and all the different tools, and then you click approve or deny for different specifications. So with X402, that's not really a thing that it does today, but we do have the contribution models. If you want to contribute it as a pull request, you're more than welcome to.
Very good. Next one here might be for Keith and Connor. So, and I'll translate the language a little bit to say, how similar is the process that you described when you were talking about certificates to getting an SSL certificate and domain/DNS, but now in the context of AI agents? How similar or equivalent are those processes?
And I think I would say they're essentially exactly the same, with the addition of independently verifiable claims and history.
Yeah.
And so, oh, go ahead, Keith.
I was going to say, and then also, we're getting a identity cert here as well. So it's like the dual cert model. So very similar, but
makes a lot of sense. All right, so let's see this follow-up question from the real Emmanuel, which is, for non-technical users delegating tasks to autonomous agents, can local guardrails rely on verified compliance certificates to handle approvals automatically in the background?
I think the big advantage, go ahead.
No, you go, Keith.
I was going to say, I think the big advantage of using ANS anytime you're delegating any task to autonomous agents is just that you'll be able to figure out who did something. And that's kind of, it'd be verified that was that agent. As far as what it does, that's a whole nother ball of wax, but.
All right. Question from Henry here. Since the ANS uses standards not tied to Web3 and that already exist for a long time, does this mean that this can also be used for Web2 agents and projects?
Yes. Yeah, and I think that's really the base of ANS, is it's built on top of the infrastructure that is currently widely used across the internet. And then, of course, also tying in some of the Web3 strengths like consensus.
Very good. All right, so for this question, I know you guys went deep into it. I like that progression, comparing it to an airport process. But how does ANS prevent an agent from impersonating another agent?
If you want me to take this one, Keith?
Yeah.
Okay. I think I'll get a little bit technical here. So really it all comes down to proof of possession. And so those identity certificates that are issued along with the SCIT receipts and the transparency log allow independent verification that an entry is actually committed to an ANS registry, that it hasn't been tampered with, And then also that the agent has proof of possession of the private key that was issued during the registration. That sort of ties the runtime identity to the registration inside the transparency log and the registration authority system. And so simply, I mean, this is the same infrastructure that runs, every commerce website, every SSL or encrypted website communication is essentially the same thing. This is just sort of tying them together to agents from both the client and server side.
Yeah, and there's kind of those three components, right? You got this get receipt that ties that back to the transparency log cryptographically, and then the status token makes sure it's recent, right? It's not like just some old status token laying around or get receipt laying around. So it could have been revoked, right? And so that status token kind of verifies that part, and then as Connor said, the third piece is that key.
And the status tokens are short-lived,
right?
So to be continually refreshed.
Absolutely. Thank you, guys. All right. So just a reminder for the audience, if you have any more questions, please drop them in the chat. Also, contact us, and we're happy to follow up and provide answers as you watch the recording. But while more questions coming in the chat, can we also bring Ty to the stage, just to make it part of the conversation here? But I would like to start transitioning towards any closing thoughts, any trends and call to actions that we should be sharing with the audience here today. So, Ty, we can probably start with you since you're fresh back up on the stage.
Closing action, do we in a target or just like in general? What is the?
I would say in general. Yeah, thinking about closing statements as we reach the top of the hour here.
Yeah, so when you're thinking about creating a key for your HCS 14 identity for your agent, if it's touching Hedera, I would recommend an ECDSA with the correct EVM alias. But in more broad terms, we're seeing the trajectory of AI kind of take this, okay, what can an agent do for me? How does it execute for me? How do I get it to execute better? So then now we're getting into the context. And then we're getting to, I think, where most of the industry are people behind the bleeding edge. How do I get my agent to have correct context and talk to my other cohort and get their context, and how do we work together? And so the obvious next stage from there is, okay, so now we're working in a swarm, and then we have another swarm in either a marketing team and we're engineering, or our company wants to talk to another company's swarm. How do we identify, connect, understand that that connection's secure, know that we're not being spoofed? And I think that's where GoDaddy and where HOL's mind is at, is this ANS solution would allow you to have this exact interoperability, searchability, and the reinventing the internet for agents. Essentially, the first thing I talked about is an AI intranet. There's nothing different, really. It's just, how does my autonomous computer find and talk to other autonomous computers to execute knowledge and context graphs? So it's really exciting times, I think, in technology, where we get to see this reinvention. And if you're a technologist or someone writing code or someone who wants to, now's the time to just sort of dig in and contribute to ANS, contribute to HOL standards or HIRO standards, join the meetings and just be a fly on the wall. Have your Claude agent be a fly on the wall with you, and then ask the questions where you're confused. The ability to learn knowledge is so high right now. So if you're curious, make sure you engage that curiosity and use the tools to teach yourself and learn in this very exciting time and influx in how technology works.
Very well said, Ty, and beautiful way to thread the needle there, of both topics, recommending folks to, create accounts with ECDSA keys for working with HCS 14 as well. Keith, let's transition over to you and see, please share with us any closing thoughts or things that the audience should be thinking about here in terms of trends or next steps.
Yeah, I just want to tack on to what Ty said. I mean, we'd love anyone that, just come poke at Agent Name Service, go to the open source repos, check out the specs, check out the code, run it. You can get up an ANS instance up and running in like a minute. So try it out, play around. Let us know what works and what doesn't.
Awesome. Connor, and then we'll close with Michael's thoughts.
I don't really have a whole lot to add on top of that. I echo Ty and Keith's statements, but if you have any questions, you can reach out to Keith or I, or post an issue on GitHub. Yeah.
Awesome.
The big thing that a lot of folks are kind of interested in, I saw some of the comments spread into the chat here today that I think about too quite a bit. When we started building HLL, we thought that agents would kind of take off immediately and we'd all start using them. And we realized quite quickly, we're not there yet. Number one, we have so many standards that we still need to build so that any of this can actually work at scale. These standards still don't exist, and we're still coming together at putting them together. And when I say we, I don't mean the folks in this room. I mean everyone in the industry, from the AI industry, from the web industry, organizations like the IEEE, W3C, the Linux Foundation, Google, and so forth. These things are still being built. Two, the cost of tokens and inference is still quite high. So actually going to an agent saying, hey, I have $10,000 worth of USDC, go and make money from me, is probably not worth it. You're probably better off creating your own bot and having it do that than having an artificial entity, because you'll spend more money having it ping every millisecond to keep checking on price and adjusting its algorithm than you would if you just built your own thing to do that. But that's changing very quickly. Number one, you've got new open source models like DeepSeek Flash. You can run that on $10,000 worth of hardware, which technically just counting in electricity is a lot cheaper than going and paying for inference. And we just need that to get 10 times cheaper. And when that happens, then naturally we're going to see a lot more agents. And when there's a lot more agents, we have to be prepared. We have to have standards. We need infrastructure in place. And most importantly, we need things like ANS there for us so that we can verify all these agents and their identity and have a way to talk to them, right? So that's why I think this conversation is so important. That's why I think the work that GoDaddy is doing is so important, because maybe it's 6 months from now, maybe it's a year from now, maybe it's 2 years from now, where a model ships that anyone can run on their laptop or their phone, or maybe there's hardware that Mac or Windows, whatever, ships that makes it possible to do that. And things will get really crazy and they're going to take off. So we're building for that future, and that's really important work. So if you do want to participate, go to GoDaddy's GitHub, go participate in the HLL Partner Program, participate in standards that are being built here on Hedera through the Hyro improvement proposals process and so forth. There's a lot of great things that are being worked on here. So with that said, let's build this new agentic internet together.
Amazing. Very well said, Michael. And I believe it's very reasonable to expect that we'll have more agents, that we'll have humans. And so it's amazing to have these spaces with you folks and everyone in the industry building these standards and these rails for that agentic economy, to do commerce, to have identity, and also all the considerations that pile on top of those different layers. So guys, thank you so much for the time, for the information, and for the very informative dialogue here. Pleasure to have you all, and have a great rest of the week.
Thanks.
Introducing the Hedera AI Agent Kit, the easiest way to build intelligent on-chain agents. Designed for developers, it's a modular, open-source toolkit to build, deploy, and scale trusted AI agents on Hedera, powering a more connected digital economy. With the AI Agent Kit, you can build agents integrated with industry-leading LLMs. Use industry-standard tools like LangChain, Vercel, AI SDK, ELIZA OS, or MCP to build agents that do more than just talk, from concept to deployment. Agents built with the kit can create tokens through the Hedera Token Service, sign and send transactions, post to the Hedera Consensus Service, and call smart contracts, all autonomously or with human oversight. Thanks to Hedera's fixed fees, security, and fast finality, agents run with the predictability and performance needed for real-world applications. Most importantly, everything is verifiable. Each action your agent takes can be logged on-chain using Hedera Consensus Service, enabling trust, auditability, and compliance. With pre-built plugins, connecting your agents to decentralized exchanges and lending protocols is easier than ever, enabling autonomous DeFi operations out of the box. Intelligent agents, verified actions, transparent results. This is where scalable AI meets decentralized trust. What future will you build?